Hello students, today we will learn section 7.3, Multivariate Linear Systems and Row Operations. The main focus today is we're going to solve a 3x3 system by reduced row echelon form. In the last section, 7.2, we discussed briefly this is what we call an identity matrix. What we will have to do is manipulate the matrix such that it's going to be the identity matrix. Zeros in column 1, zeros in column 2, zeros in column 3, and a diagonal of 1s. So when we start solving the system by row echelon form, we want to get zeros in column 1 first, and then zeros in column 2, zeros in column 3, and then get the diagonal of 1s. So here is example 1. We have a 3x3 system, 3 equations, 3 variables. We will write the coefficient matrix. Coefficient matrix are the coefficients of our system. So for example, 1, 2, negative 1, 1, 2, negative 1. This broken line represents the equal signs. And then we have negative 3, 0, 7, 2, negative 1, negative 3, 2, negative 1, negative 3, negative 1, 1, 2, negative 1, 1, 2. So what we are going to do now is make these two positions 0 by using row 1. We're going to use row 1 to make these two zeros. So what we came up with was 2 times row 1 minus row 2. So 2 times 1 is 2 minus 2. There's the 0. We also want this to be 0. So we're going to use row 1 plus row 3. 1 plus negative 1, there's our 0. So this is what we have. We are not going to change row 1, so write down row 1 immediately. We are not changing it. In red, that's what we've changed. So we're just going to apply this rule. 2 times row 1 minus row 2. 1 minus 2, 0. 2 times negative 1, negative 2, minus 1, negative 3. 2 times 2 is 4, minus a negative 1, which is 5. And then we have 2 times negative 3, negative 6, minus 0 is negative 6. Now we're going to use row 1 and row 3. Row 1 plus negative 1, row 1 plus row 3, 1 plus negative 1 is 0. Negative 1 plus 2, 1. 2 plus negative 3, negative 1. And negative 3 plus 7 is 4. We have gotten our zeros for column 1. Next thing we're going to do is make these two zeros by using row 2. So we are going to change row 1 and row 3, but we are not going to change row 2. So we're going to write down row 2 immediately. So here is row 2, not changed. 0, negative 3, 5, negative 6. So now to use this row, making this 0 and 0, if this was a positive 3, negative 3 plus 3, we will get our 0. So that's what we're going to do. We're going to take row 2 minus 3 times row 1. So negative 3 minus a negative 3, which is positive 3, will be 0. 0 minus 3, negative 3. 5 minus 6, 5 minus 6, negative 1. And we'll have negative 6 plus 9, which is 3. Negative 6 plus 9 equals 3. Row 3. It says take row 2 plus 3 times row 3. So 0 plus 3 times 0, 0. Negative 3 plus 3, there's our 0. 5 plus negative 3, 5 plus negative 3 is positive 2. And then we'll have negative 6 plus 12. Negative 6 plus 12, 6. So again, we've gotten these two to be 0. That's what we want. The next thing we're going to work on is we're going to work on these two positions to be 0 using row 3. So the same patterns up is from the previous steps. Right, row 3. We're not changing row 3. So that's what we did. We wrote row 3 immediately. We're not changing it. We're going to change row 1 and row 2. That's why it's in red. So looking here, if you take row 3 right here, if this is 2, we need this to be a negative 2. So multiply by 2. That's how I'm coming up with this number. 2 minus 2, there's our 0. So starting with row 3 and row 1, here we go. 0 plus negative 6, negative 6. 0 plus negative 6, negative 6. Row 3. 0 plus 2 times row 1, which is 0, is 0. So 0 plus 0 is 0. Next. 2 plus negative 2. 2 plus negative 2, there's our 0. And we will have 6 plus 6. 6 plus 6, 12. Now we'll work with row 3 and row 2. There is 0 minus 0, 0. 0, 5 times 0 is 0, plus 6. 0 plus 6, 6. 10 minus 10, 0. There's our 0. And this is 30 plus 12, which is 42. We now have our surrounding zeros. Now we need a diagonal of 1s. Well, to get this to be 1, we're just going to divide by the same number. So we're going to take row 1 divided by negative 6. We need this to be 1, so we're going to take this number divided by 6. We'll get our 1. We need this to be 1, so we'll take this row divided by 2. 2 divided by 2 is 1, but we have to take the entire row. So here's the rule for the next matrix. As you can see, negative 6 divided by negative 6, 1. 0 divided by negative 6, 0. 0 divided by negative 6, 0. And 12 divided by negative 6, negative 2. The rule for row 2, we take the row 2 and divide it by 6. 0 divided by 6, 0. 6 divided by 6, 1. 0 divided by 6, 0. 42 divided by 6, 7. We'll take this next row. Divided by 2. Row 3 divided by 2. And as you can see, nothing is in black. Everything is now in red because we're changing the entire system. We're changing all the rows. So we'll have 0 divided by 2, 0. 0 divided by 2, 0. 2 divided by 2, 1. 6 divided by 2 is 3. Since the column 1 represents x, column 2 represents y, column 3 represents z, we have x, 1x plus 0y plus 0z equals negative 2. Therefore, x equals negative 2, y equals 7, z equals 3. Or you will see your answers written as an ordered triple, x, y, z. Please be patient with this. You'll have to try it several times before you can get the right answer. So be very, very organized when you write down your work. Again, we're trying to get these two to be zeros first by using row 1. We didn't change row 1. Next, we're trying to get these two to be zeros by using row 2. We're not changing row 2. Write row 2 right away. And now we don't want to change row 3. So write row 3 down right away and find a rule to use row 3 with rows 1 and 2 to get your zeros. Again, after we get our surrounding zeros, we'll just use this number to divide by to get 1. Same for this, same for this. Once you get your identity matrix, you will get your solution. Be patient. Thank you. Have a good day.